So I'm working on the ultra compact combustor. It's also known as a UCC. It's designed as a replacement combustor for a jet engine. So a traditional engine burns basically from front to back. What we're able to do is picture burning inside of a donut, if you will. So rather than flowing from front to back, we can burn in a circle. And by using a circumferential length or a circular length, we can shorten the overall combustion length of an engine by saving up to 33%. The benefit, we have a drastic length savings, but a combustor is a very heavy section of a jet engine. There's a lot of metal, there's a lot of heat, so there's a lot of metal to hold, be able to withstand that heat. Additionally, there's a lot of cooling requirements, so there's a lot of tubes and ducting inside that component. By shortening the length, we can significantly reduce the weight of an engine as well. Shorter engines lead to more room for avionics, weapons, gas, payload, essentially.
He is, not surprisingly, one of the best students I've ever had. He's sharp, he's intelligent, highly resourceful. There's been a number of instances where we'll talk about a project, or we'll talk about, hey, wouldn't it be cool if we tried this? And he's like, well, yeah, I've already done that. I'm like, really? You've already? Yeah, I've already got the CFD code running. It's been working for 12 hours already. And I'm like, we just started talking about this. And so he's got that mentality of how to not wait for people to tell him what to do. He's the go-getter. He's the one that wants to make things happen, and he's going to do it on his own.
So I'm hoping at some point in the near future that my work will directly lead to taking an ultra compact combustor from a lab demonstration into a production level hardware. Additive manufacturing really has been a force multiplier for us. We can take something from a CAD model and a design to a concept into testing and production in a much shorter length of time. We now have the capability to increase internal passages and fixturing, something that would have taken 30 parts, individual little parts made up by a machine shop. We can now print as one continuous part. I think what it means to be an AFIT student is to have an impact and to make a difference. As a student, as a major in the Air Force, I have the potential to affect the way that jet engines operate. What I'm working on could have an impact on every engine in the airframe and every airframe in the inventory, from the smallest cruise missile engine all the way up to the giant turbofans of the C-17, and really everything in between. So that's really huge. To be an AFIT student is to make a difference and to leave your mark.